Okay, Assalamualaikum warahmatullahi wabarakatuh. On this video, I want to discuss on a remedial exercise on chapter 8, acid and base. Okay, let's look at section A. Okay, which of the following is a form when a metal oxide react with a dilute acid? Okay, so on this question, student must know and remember the chemical equations of acid. Okay, so acids can react with metal, acid can react with base, and acid can react with metal carbonate. But in this question, it asks about the reaction of acid with the base. Okay, so when metal react with base, the product is metal salt. Yes, is salt and water, not hydrogen gas. Okay, this is the reaction between acid and metal. So that's why 3 is not the answer. Okay, number 1, the answer is B. Now question 2. Okay, lactic acid is produced in muscle under anaerobic condition. What is the conjugate base? Okay, conjugate base. Okay, please remember that between difference between acid and conjugate base is differ by 1 proton. Okay, so this is what is the conjugate base? Meaning that C3H6O3 is acid. Okay, and what's the role of acid? Acid donate a proton to base. So when it donate proton, it will lose 1 hydrogen. So the formula of the product is H5O3. Okay, what is the charge of the product? Okay, when the compound lost proton, it will become negative charge because the proton have positive charge. Okay, so based on the lactic acid actually is neutral. Neutral meaning that the number of proton and number of electron is equal. Okay, now when it lost 1 proton, of course the number of electron more than proton. Okay, when the number of electron more than proton, the charge of compound now become negative. Okay, so the answer is C. Okay, so opposite reaction, if the compound donate proton, if the compound gain proton, it will become positive charge. Okay, number 3, what is the conjugate acid of H2SO4? Okay, so H2SO4 produce a substance. Okay, actually this is a base because the product is conjugate acid. So what is the role of base? Base gain 1 proton. When it gain 1 proton, it will become H3SO4, and when receive proton, of course the charge become positive. So the answer is B. Okay, alright, the next question, consider the equilibrium below. Okay, this one is a propanoic acid react with water and produce propanoic ion and hydronium ion. Which bases represent the conjugate base pair? Okay, so based on this question, okay, propanoic acid is paired with propanoid and H2O is paired with hydronium ion. Alright, so based on the answer, C is correct. Okay, next question, number 5. A solution of acid A has a pH 1 and a solution of acid B has a pH of 2. Which statement must be correct? Okay, so we have acid A, pH is 1, and acid B, pH is 2. Both of these acid actually is a strong acid, okay, because the pH is below than 2 and below. Okay, acid A is stronger than acid B. Okay, it's quite true. Okay, we look at B. Concentration of A is higher than concentration of B. Okay, next, see the concentration of hydrogen ions in A higher than in B, and D, the concentration of hydrogen ion in B is twice the concentration of hydrogen ion in A. Also, okay, so D is wrong actually, because if the concentration of B is twice of the concentration of hydrogen, of course B have low pH value compared to A. Okay, now A, B, C, which one is the most correct answer? Okay, the most correct answer is the concentration of hydrogen ion in A is higher than B. Okay, remember that concentration of hydrogen ion will affect the pH value. Okay, what is the difference between answer B? Answer B is for the overall compound. I give one example. Let's say I have 0.1 molar HCl and 0.1 molar H2SO4. Okay, this is more to answer B, which is the concentration of HCl equal to the concentration of H2SO4. But the but the pH is not same because it not affect the concentration of substance, but it affected by the concentration of hydrogen ion. So we know that the H2SO4 is a diprotic acid. So concentration of hydrogen ion is 0.2, and HCl concentration of hydrogen ion is 0.1 because this is monoprotic. Okay, so in this case, concentration of hydrogen ion of sulfuric acid bigger than concentration of HCl. So of course, pH value for H2SO4, okay, is low than pH of HCl. Okay, so that's why the answer is C. Okay, the pH value are affected by the concentration of hydrogen ion, not the concentration of the substance. Okay. Okay, next question. Okay, question 6. When the pH of a solution changes from 2 to 4, the hydrogen ion concentration. Okay, this about the factor. Okay, based on this question, student must know that. Okay, let's say that this is a line of pH. Is pH 1, 0, 1, 2, 3, 4, 5, and so on. Okay, when the pH increase one value, it was equal to the increasing 10 times of concentration hydrogen ion. So every time the pH value increase one value, the concentration increase 10 times. Okay, when the pH increase from 2 to 3 pH, concentration of hydrogen ion increase 10 times. Right? So if you refer on this question, okay, from 2 pH to 4, okay, how many times concentration increase? Sorry, how many times the concentration decrease? Okay, when the pH increase, the concentration decrease. Okay, pH increase equal to concentration of hydrogen ion decrease. So in this case, concentration of hydrogen ion decrease by 100 because it was equal to the 10 times. Okay, 100. So the factor is 100. The answer is D. Okay, question number 7. What is the pOH of 0.05 molar solution of sulfuric acid? Okay, so on this part, okay, I have one formula, and the student must know the formula, which is, okay, we know that the ion product constant is equal to Kw equal to concentration of hydrogen ion times concentration of hydroxide ion. Okay, so concentration of so Kw is equal negative log Kw equal to negative log hydrogen ion plus negative log hydroxide ion. So the value of Kw is 14. Okay, and negative log H, we will find the value of pH, because the formula how to find the pH is equal to negative log concentration of hydrogen ion. Okay, and how to find the pOH is equal to negative log concentration hydroxide ion, so equal to plus pOH. Okay, so if you refer on this question, okay, we use this second formula, which is negative log Kw is equal to 14. Okay, so pOH, okay, just convert the equation. pOH equal to okay, 14 minus pH, and equal to 14 minus, what is pH? pH is negative log hydrogen ion, so 14 plus log hydrogen ion. Okay, so actually we use this formula, this one. Okay, and then we convert again to the log. Okay, so that's why the answer is D. Okay, so concentration of hydrogen ion, okay, 0.05 H2SO4 equal to 2 times 0.05 hydrogen ion, because this is diprotic acid, so 0.10. Okay, alright, now the value is 14 plus log 0.10. okay, so the answer is D. Okay, next question. Question 8. A solution of sodium hydroxide contain 0.80 gram of sodium hydroxide per 100 centimeter cube of solution. Estimate the pH of solution. Okay, so in this based on this question, okay, the first step is calculate the mole of sodium hydroxide. Why? Because we want to calculate the concentration of sodium hydroxide. Okay, so okay, mole is equal to 0.8 gram, okay, over molar mass. So molar mass is 23 plus 16 plus 1.008. Okay, so just total the value. Okay, so the molar mass is 40.008. Okay, and the answer, okay, let's say this is X mole. Okay, right, and then from mole we calculate the concentration. Okay, so concentration of NaOH equal to X mole divided by divided by volume, so 0.1 decimeter cube. Okay, convert into decimeter cube. Okay, 1, 2, 3, 0.100 decimeter cube. Okay, and then you will find the concentration is, let's say the concentration is X and Y mole per decimeter cube. Okay, and then from this concentration, okay, is equal the concentration of sodium hydroxide equal to concentration of hydroxide ion, right? So how to find the hydrogen ion? Okay, by using the formula of Kw, okay, equal to concentration of hydrogen ion times concentration of hydroxide ion. 1.0 times 10 negative 14 equal to hydrogen ion times Y concentration, and then concentration of hydrogen ion equal to 1.0 times 10 negative 14 divided by Y. Okay, so I'm not calculate, you have to calculate by yourself. And then okay, let's say the concentration is P molar, or mole per decimeter cube. Then from this concentration we can calculate the pH, which is negative log P, and you will find the answer 13.3, 13.30. Okay, try to calculate by yourself. Okay, next question. Okay, 100 centimeter cube of sodium hydroxide solution of pH 12 is mixed with 900 centimeter cube of water. What is the pH of the resulting solution? Okay, on this question is about the ratio changing of the concentration, right? Okay, let's say I have, okay, this one is 100 centimeter cube sodium hydroxide with pH 12, and I add 100 centimeter cube of water. Okay, what happened is, okay, now I have sodium hydroxide with volume 1000 centimeter cube, and I don't know what is the pH. Okay, remember that. Okay, okay, so before that we have to calculate what is the factor that increase the volume, okay, so from 100 centimeter cube, okay, increase 10 times, okay, increase 10 times to form 1000 centimeter cube. Okay, so when the volume increase 10 times, meaning that the concentration of hydrogen ion will decrease 10 times. Okay, will decrease 10 times. Okay, and when the concentration of hydrogen ion decrease 10 times, meaning that the pH value will decrease by 1. Okay, will decrease by 1. So from 12, okay, the concentration decrease, okay, when the concentration of hydrogen ion decrease, pH increase, okay, sorry, pH increase, so it will increase to 13. Okay, alright, okay, so from 12, okay, the concentration increase. Okay, the answer is C. 11, okay, wait, okay, a concentration of hydrogen ion decrease, of course pH will increase, okay, what is the pH of the resulting solution? Okay, actually the pH must increase, not decrease. Okay, so the answer actually must D. Okay, So we try to look at the basic from the basic. Okay, pH 12. Okay, right, and okay, 100 increase 10 times. Yes, of course, concentration will decrease. pH increase. Alright. Yes, actually it must increase. Okay, by 1. Okay. Next question. Which method will distinguish between equivalent solution of a strong base and a strong acid? Okay, so how to distinguish which is this is a strong base or a strong acid? Okay, how to identify? Okay, let's say I have a strong acid and react with strong base. How we can observe based on the experiments? So when we add magnesium to each solution and look for the formation of gas bubble. Yes, of course, because base can react with metal and acid also can react with metal, and we can observe based on the bubble of gas. Okay, so when it produces a lot of bubble gas, of course this is a strong base or strong acid. Okay, and add aqueous sodium hydroxide to each solution and measure the temperature change. Okay, so for the strong acid or strong base, they have a lot of hydrogen ion, and they can okay, they have a lot of hydrogen ion. Okay, and okay, strong acid and strong base, they are dissociates completely in water. So when it dissociates completely in water, of course the temperature change is increased. If weak acid or weak base, okay, they are dissociates partially. So the heat produced will use to ionize any non-ionized acid. Okay, let's say I have weak acid. Example, CH3COOH. Okay, actually it will produce CH3COH plus CH3COO and hydrogen ion. Okay, this is for weak acid. Why? Because it ionized partially, not completely ionized. So when it produces heat, that heat will use to ionize this ethanoic acid. That's why if a weak acid or weak base, they have temperature change less than strong acid and strong base. Okay, so number 2 is correct. Okay, number 3, use each solution in a circuit with a battery and lamp and see how bright the lamp glows. Okay, use a solution. Okay, this is related to the amount of hydrogen ion or amount of hydroxide ion. So when the number of ion increase, it can carry electricity very well. Okay, when it can when it become a better electricity carrier, so it will produce bright lamp. Okay, so the answer is 1, 2 and 3. Okay, so for the part B, I will continue